Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache Maven. Maven is a powerful build automation tool primarily used for Java projects. It helps developers manage project structure, dependencies, and build processes through a declarative approach. By using a project object model or POM, Maven ensures consistency across projects and simplifies complex build workflows. Whether you're managing a simple application or a large enterprise system, Maven streamlines your development lifecycle. So why should you use Apache Maven? First, it automates repetitive build tasks like compiling code, running tests, and packaging applications. This reduces manual errors and saves valuable development time. Second, Maven excels at dependency management, automatically resolving and downloading required libraries along with their transitive dependencies. Finally, it enforces a consistent project structure, making it easier for teams to collaborate and onboard new developers. Let's explore Maven's core concepts. At the heart of Maven is the Project Object Model or POM, defined in the pom.xml file. This XML configuration contains project metadata like group ID, artifact ID, and version, along with dependencies and build settings. Maven also enforces a standard directory structure, with source code in src/main/java and tests in src/tests/java. This consistency simplifies navigation and tool integration across projects. Maven organizes build processes into lifecycles. There are three main lifecycles: default, clean, and site. The default lifecycle handles the core build process, including phases like compile, test, package, install, and deploy. Each phase executes associated plugin goals in a specific order, ensuring that dependencies between tasks are properly managed. For example, you can't package an application without first compiling it. Let's dive deeper into Maven's build phases. The compile phase converts your Java source code into bytecode using the compiler plugin. Next, the test phase executes unit tests, typically using frameworks like JUnit or TestNG. The package phase then bundles your compiled code and resources into distributable formats like JAR or WAR files. These phases work together seamlessly to produce production-ready artifacts. One of Maven's strongest features is dependency management. You declare dependencies in your pom.xml using their group ID, artifact ID, and version coordinates. Maven automatically resolves these dependencies by checking your local repository first, then downloading from remote repositories like Maven Central if needed. It also handles transitive dependencies libraries that your dependencies require and provides mechanisms to exclude unwanted ones. Maven uses dependency scopes to control when libraries are included in your project. The compile scope is the default and includes dependencies for both compilation and runtime. Test scope dependencies are only available during test compilation and execution, like JUnit. Provided scope is for dependencies that will be provided by the runtime environment, such as servlet APIs in web applications. Understanding scopes helps optimize your application's footprint. Maven uses repositories to store and retrieve dependencies. Your local repository acts as a cache on your machine, storing copies of dependencies you've downloaded. Remote repositories, like Maven Central, host publicly available libraries. Enterprises often configure custom repositories for internal libraries. When you build a project, Maven checks these repositories in order to resolve your dependencies, ensuring you always have the right versions. Maven's extensibility comes from its plugin system. Plugins provide goals that execute during specific build lifecycle phases. For example, the compiler plugin runs during the compile phase, while the Surefire plugin executes tests. The JAR plugin packages your application. You can also develop custom plugins for specialized tasks. This modular approach allows Maven to handle diverse project requirements while maintaining a consistent interface. For complex projects, Maven supports multi-module structures. An aggregator project coordinates multiple related modules, each with its own pom.xml. Maven's reactor mechanism ensures proper build order, especially when modules depend on each other. You can also use parent POMs to share common configurations across modules, reducing duplication and ensuring consistency. This approach is invaluable for large enterprise applications. The Maven Wrapper addresses version consistency challenges. Instead of requiring everyone to install the same Maven version, you include a mvnw script in your project. This script automatically downloads and uses the correct Maven version specified in your wrapper configuration. It's stored in the .mvn directory and ensures that all developers and CI systems use the exact same build environment, eliminating works on my machine issues. Let's look at essential Maven commands you'll use daily. Mvn compile converts your source code to bytecode in the target directory. Mvn test runs all unit tests and generates detailed reports. Mvn package creates distributable artifacts like JAR or WAR files. Other important commands include mvn clean to remove generated files, mvn install to add artifacts to your local repository, and mvn deploy to upload to remote repositories. Maven provides powerful tools for dependency analysis. The mvn dependency tree command visualizes your complete dependency hierarchy, helping you understand what libraries are included and why. Mvn dependency analyze identifies unused dependencies and missing direct dependencies. You can also view the effective POM, which shows the complete configuration after merging with parent POMs and applying defaults. These tools are essential for maintaining clean, efficient projects. Maven profiles allow you to customize builds for different environments. You can define profiles for development, testing, and production with different dependencies, plugin configurations, or resource filters. Profiles can be activated automatically based on JDK version, operating system, or custom properties, or manually triggered during builds. This flexibility is crucial for managing environment-specific configurations without duplicating entire projects. Modern IDEs like IntelliJ IDEA and Eclipse provide excellent Maven integration. You can import Maven projects directly using the pom.xml file, and the IDE will automatically resolve dependencies and configure the project structure. This integration offers real-time dependency resolution, code completion, and navigation features. You can also execute Maven goals directly from the IDE, making development workflows more efficient and streamlined. Maven integrates seamlessly with CI/CD pipelines. Tools like Jenkins, GitLab CI, and GitHub Actions can automatically execute Maven builds when you push code changes. The standardized build process ensures consistency across development, testing, and production environments. You can automate artifact deployment to repositories, trigger notifications, and implement quality gates. This automation accelerates delivery while maintaining quality standards. While Maven is powerful, build performance can be a concern for large projects. The Maven daemon or MVND significantly reduces startup time by keeping Maven processes alive between builds. You can enable parallel builds with the T flag to utilize multiple CPU cores. Incremental compilation only rebuilds modules that have changed, and proper dependency management reduces unnecessary downloads. These optimizations can dramatically improve build times. When choosing build tools, developers often compare Maven with Gradle. Maven uses XML for configuration, which is verbose but familiar to many developers. Gradle uses Groovy or Kotlin DSL, offering more flexibility and conciseness. Gradle typically provides better performance with incremental builds and build caching. However, Maven has a more mature ecosystem and wider enterprise adoption. The choice depends on your specific requirements and team expertise. Following best practices ensures maintainable Maven projects. Use meaningful group ID and artifact ID following reverse domain naming conventions. Keep your pom.xml clean by using properties for version numbers and organizing dependencies in dependency management sections. Regularly update dependencies to benefit from security patches and new features, and remove unused dependencies to reduce application size. These practices contribute to robust, maintainable projects. Even with Maven's robust design, you may encounter common issues. Dependency conflicts occur when different libraries require incompatible versions of the same dependency. Resolve these using exclusions. When internet access is unavailable, use the offline flag for offline builds. If your local repository becomes corrupted, you can delete problematic artifacts to force redownloads. Understanding these troubleshooting techniques saves valuable development time. Security is crucial in modern software development. Use dependency check plugins to identify vulnerable libraries in your project. Configure proper repository authentication when accessing private artifact repositories. Regular security audits should be integrated into your development process. Maven's ecosystem provides tools to help you maintain secure projects, but vigilance and proactive measures are essential for protecting your applications. Maven Archetypes are project templates that help you quickly bootstrap new projects. They provide predefined structures for common project types like simple Java applications, web applications, or multi-module projects. You can generate a new project from an archetype with a single command, saving setup time. Organizations can also create custom archetypes for their specific project templates, ensuring consistency across all development initiatives. Maven excels at documentation generation through its Site plugin. This plugin creates comprehensive project documentation including dependency information, test results, and code coverage reports. It integrates seamlessly with tools like JavaDoc for API documentation. You can also add custom reports through plugin configurations, creating a centralized documentation hub for your project. Good documentation is essential for maintainable software. In enterprise environments, Maven requires specific configurations for security and consistency. Corporate repositories can proxy remote dependencies, providing security control and caching benefits. A centralized settings.xml file enforces organization-wide policies like repository access and authentication. Mirror configurations ensure developers access repositories through approved channels. These configurations create a controlled, efficient development environment. Maven's release process streamlines version management and deployment. The release plugin automates version increments, creates tags in your source control system, and deploys release artifacts. It supports both major and minor version strategies, ensuring proper semantic versioning. Integration with SCM systems like Git automates version control operations. This automation reduces human error and ensures consistent release practices across your organization. Advanced Maven users can customize plugin behavior extensively. Plugin executions can be explicitly bound to specific lifecycle phases, giving you fine-grained control over the build process. Configuration inheritance allows you to share plugin settings across multi-module projects, reducing duplication. For specialized requirements, you can develop custom plugins that extend Maven's capabilities. This flexibility makes Maven adaptable to virtually any build requirement. Maven properties and filtering provide powerful configuration capabilities. Built-in properties give you access to project metadata, environment information, and system properties. Resource filtering allows you to replace placeholders in configuration files with actual values during the build process. You can define custom properties for project-specific configurations, making your builds more flexible and environment-aware. This feature is essential for managing configuration across different deployment environments. Understanding build performance is crucial for large projects. Maven Profiler plugins can identify performance bottlenecks in your builds, showing which phases and plugins consume the most time. Build time analysis helps you optimize slow processes and make informed decisions about build improvements. Parallel build analysis reveals CPU utilization patterns and efficiency, guiding you toward optimal build configurations. These insights are invaluable for maintaining fast, efficient builds. Many organizations migrate from Apache Ant to Maven for better project management. While Ant offers maximum flexibility with procedural build scripts, Maven provides standardized project structures that improve collaboration. Maven's automatic dependency management replaces the manual library handling required in Ant. The declarative approach of Maven, specifying what you want rather than how to build it, simplifies maintenance. Migration requires understanding these paradigm shifts but delivers long-term benefits. Maven benefits from a vibrant community and robust ecosystem. The Apache Software Foundation maintains regular releases and security updates. An active community provides support through mailing lists, forums, and issue trackers. The extensive plugin ecosystem hosted on Maven Central offers solutions for almost any build requirement. This strong foundation ensures that Maven remains a reliable, evolving tool for Java development projects. Maven continues to evolve with modern development practices. It integrates seamlessly with containerization tools like Docker, enabling consistent builds for containerized applications. Support for microservices architecture through modular builds allows teams to develop, test, and deploy services independently. Maven's compatibility with cloud-native development practices makes it a relevant choice for contemporary software projects, bridging traditional and modern development approaches. To continue your Maven journey, leverage diverse learning resources. The official Maven documentation provides comprehensive guides and reference materials. Online tutorials and courses offer hands-on learning experiences that reinforce concepts through practice. Community forums and platforms like Stack Overflow provide practical problem-solving assistance. Start with simple projects, gradually incorporating advanced features as you become more comfortable with Maven's capabilities. Understanding Maven's architecture is key to mastering the tool. The Project Object Model or POM serves as the central configuration, driving the entire build process with project metadata, dependencies, and plugin configurations. The repository system manages dependency resolution and artifact storage, coordinating between local and remote repositories. The plugin framework executes goals during defined lifecycle phases, providing extensibility for custom build requirements. Maven's build lifecycle workflow orchestrates the entire development process. The default lifecycle processes source code through sequential phases: validate, compile, test, package, verify, install, and deploy. The clean lifecycle removes all generated files and artifacts, ensuring fresh builds. The site lifecycle generates comprehensive project documentation and reports. Understanding this workflow helps you leverage Maven's full potential for automated, consistent builds. In real-world implementations, Maven proves its value across diverse scenarios. Enterprise applications leverage multi-module structures for scalability and maintainability, with shared parent configurations ensuring consistency. CI/CD pipelines automate Maven builds for continuous integration and delivery, reducing manual intervention. Advanced dependency management ensures consistent library versions across development teams, preventing compatibility issues. These implementations demonstrate Maven's robustness in production environments. Performance optimization is crucial for large-scale Maven projects. The Maven daemon significantly reduces build startup times by keeping processes alive between builds. Parallel builds, enabled with the T flag, improve CPU utilization on multi-core systems. Incremental compilation optimizes rebuild times by only processing changed modules. These optimizations, combined with proper dependency management and repository configuration, can dramatically improve build efficiency. As we conclude this comprehensive tutorial, remember that Maven streamlines Java project builds through standardized processes, automated dependency management, and a rich plugin ecosystem. Its architecture promotes best practices in software development while providing the flexibility needed for complex enterprise applications. Mastering Maven requires continuous learning and hands-on practice. Start with simple projects, experiment with different configurations, and gradually incorporate advanced features. The investment in learning Maven pays dividends in productivity and project maintainability. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.